Solving compound inequalities. In this video, we'll be going over how to solve compound inequalities. For each problem, solve the inequality. If applicable, rewrite it as a single inequality and graph the solution set. So when it comes down to solving compound inequalities, a lot of the time we are going to pretend like there's two separate problems. So what I mean by that is consider 2n plus 5 is less than 9 and 7n minus 9 is less than or equal to negative 23. In this case, the compound inequality is already been split up into two parts. So what we can do is we can take the first inequality, 2n plus 5 is less than 9, and then we can solve for n. So what does that look like? Well, first we'll subtract 5 from both sides, which gives us 2n is less than 4. And then from here, we can divide both sides by 2, leaving us with n is less than 2. Okay, we're done with the first inequality. Now we can move on to the second inequality. 7n less than 9 is greater than or equal to negative 23. Okay, first of all, we will add 9 to both sides. This gives us 7n is greater than or equal to negative 14. Next, to get n by itself, we'll divide both sides by 7. This gives us n is greater than or equal to negative 2. Now remember that this problem is an AND problem. And AND problems can be rewritten as single inequalities. Right? We learned about this in our previous set of notes. And let's just write only applicable to AND. So we can rewrite this as negative 2 is less than or equal to n, which is less than 2. Now, I'm going to actually give you a little graphing shortcut. What we can do for AND problems when it comes to graphs is we can graph the left number. So we have negative 2, and we'll use the closed circle. We have 2 as an open circle. And for the purposes of this class, the intersection is actually going to be the middle part. If you use the technique from the previous set of notes, you will find that as a shortcut for the AND, it's going to be the middle section. And that'll be true for all the AND problems we do in this class. Next up, we have 29 is greater than 4x plus 1, which is greater than or equal to negative 31. So for this problem, it has been written as a single inequality. What we can do, because it's usually convenient to do so, is we can split it up, right? So we can write this as 29 is greater than 4x plus 1, and 4x plus 1 is greater than or equal to negative 31. Right? If you're having trouble seeing that, the green part is the first inequality. And it's going to be hard to do this, but the blue part is the second inequality. That's how we kind of break it up into 2 parts. right? The first two sections create the first inequality, and then the second two sections create the second inequality. And then from here we can solve, right? For 29 is greater than 4x plus 1, we will subtract 1 from both sides, which gives us 28 is greater than 4x. Then we can divide both sides by 4, which gives us 7 is greater than x. Okay, that takes care of the part in green. Now for the part in blue. The work's actually going to be really similar. We'll subtract 1 from both sides. This gives us 4x is greater than or equal to negative 32. Now we'll divide both sides by 4, which gives us x is greater than or equal to negative 8. Now, because this is an and inequality, we can rewrite this as a single version. So we have x, and x is bigger than which number? Well, it's bigger than negative 8. And x is smaller than which number? Well, it's smaller than 7. So now that we have rewritten it as a single inequality, we can do a closed circle at negative 8. We'll do an open circle at 7. And then for the intersection, it's everything that's in between. And that takes care of exercise number 2. Moving on now. So here we have an OR statement. OR isn't too different. Just like before, we can solve each inequality individually. So 10m minus 7 is less than 17m. And then we have the word OR. Then negative 6m is greater than 36. Okay, so what we'll want to do for the first inequality is we want to kill off the smaller m. And I'll do that by subtracting 10m from both sides, which gives us negative 7 is greater than 7m. From here, we'll divide both sides by 7. And so this gives us negative 1 is less than m. Or, now for the second inequality, we're going to divide both sides by negative 6. But watch out, because we divided by a negative, we do need to flip the inequality symbol. So this gives us m is less than negative 6. Now, because this is an OR statement, we cannot combine these into a single inequality. So the answer is literally negative 1 less than m, or m is less than negative 6. And we want to graph. And as it turns out, there's actually a shortcut for OR statements as well. We have negative 6 with an open circle there. We have negative 1 with an open circle there. And for AND statements, we shade the middle section. Well, for OR statements, we will shade the outside sections. Again, if you use the techniques from the previous section, you'll find that that's actually exactly what happened. For parts A and B, which were AND statements, notice that the solutions were the middle parts. And then for the OR statement, notice that the solution was the outside parts.